This is a platform for experiential learning, learning by experimentation.
Now let's start the experiment. At first, we will determine the friction and Newton's laws of motion. So as you can see here, we have used a trolley, a container, and it is connected by a string. We have taken the mass of the container as mc, and we have taken the mass of the trolley as m suffix g, that is mp, and there is a tension in the string. We will denote it by letter T. Now we will apply Newton's first law. The trolley and the container are both in the state of rest. Why?
Why are you using this camera and all? So this I got something here. What is this?
We have used a webcam which is connected to a computer. We have used this setup to capture all the experiments that we are doing, and also to analyze the data and learn and enjoy physics. Now, let's come to Newton's first law. The container and the trolley are both in the state of rest. Why are they in the state of rest? Because there are some forces responsible for them to stay in the state of rest. First, let's see the container. The container is at rest because there are two forces acting on it. There are gravitational force, which is downward in direction, and the tension force, which is upward in direction. These both forces balances together, and hence the net force acting on the container is zero, and hence it is at rest. Now let's see the trolley. For the trolley to stay in the state of rest, there are four forces responsible. They are gravitational force, which is downward in direction, a normal force which is created by carom board, and it is in upward direction, and there is a tension in the string which is in this direction, and also there is a frictional force opposing to the tension force. These four forces balances together, and so the net force acting on the trolley is zero, and hence it is in the state of rest. So what does Newton's first law say? The bodies continues to remain in the state of rest or in the state of motion until it is compelled by an external agency called force. So only the trolley is in the state of rest, and because we have not applied any external forces on it. Only it will change its state only when we apply the force on it. So now, the tension force and the frictional force are self-adjusting forces. How can we say that the tension and frictional forces are self-adjusting forces? When we increase the mass of the container by adding water droplets, the gravity on the container is increasing. Still, the container remains at rest. Why does it remain in the state of rest? Because the tension is also increasing as the gravity is increasing. Now, as the tension in the string is increasing, the frictional force will also increase. Hence, we say that tension and frictional force are self-adjusting forces. Now, friction has some limits. So, we will say that friction is limited. There is limited friction. At some point of time, when we increase the mass of the trolley continuously, at some point of time, the trolley will start to move. That is, the tension force is now greater than the frictional force. So, the trolley will move in the direction of the tensional force. And by using this simple apparatus, we can even explain Newton's second law. It moves in the direction of the tension because now the tension is greater than the frictional force.
Why did the tension become greater than friction force?
Tension is greater as a result of which it is.
What is the purpose of this experiment?
Our purpose of this experiment is to learn friction and also Newton's laws of motion.
What are the types of friction that you saw here?
There are two types of friction. There are coefficient of static friction and coefficient of kinetic friction.
Okay, what is friction?
Friction is when two surfaces are in contact with each other. When there is a attempting relative motion or relative motion, there is a force opposing this relative motion. This force is called as frictional force.
Excellent. So what is the coefficient of static friction?
It is the ratio of limiting friction to the normal.
Excellent. Then what is the coefficient of kinetic friction?
It is the ratio of friction in motion to the normal.
Okay, what is the purpose of this camera and this software?
Our purpose of the webcam and computer is to capture all the experiments that we are doing and analyze it.
In this case, what is it capturing?
It is capturing the position, time. We have used a inbuilt stopwatch here. We have used an inbuilt stopwatch which will measure the time, and we have kept a scale there. It will measure the position, and this camera will capture all these things, or will capture all these parameters, and we can observe it and analyze analyze physics and enjoy it.
Great, wonderful.
You will find links for short videos in the description below to understand this system. You can also write to me for details. sudhirmurthy.feed@gmail.com or WhatsApp 9844118615. Thank you.